Question says two spheres A and B, each of volume 100 centimeter cube, are placed on water. Density is 1 gram per centimeter cube. The sphere A is made of wood of density 0.3 gram per centimeter cube, and the sphere B is made of iron of density 8.9 gram per centimeter cube. Find the weight of each sphere and the upthrust on each sphere. Which sphere will float? Give reason. All right, so we
So
will need to find the weight
first
and the
we'll
upthrust first. Okay, yeah, Nishika, you can carry on.
first we'll list the details which they give.
Okay,
So the volume of two spheres A and B is 100 centimeter cube.
A is 100 centimeter cube
Yes,
and volume of B is
100 centimeter.
okay.
And the density of water is 1 gram centimeter cube.
Okay, density of water is given. So, okay, let me write that liquid density is 1 gram per centimeter cube. Okay, what about density of
Yes.
A?
So 0.3 gram centimeter cube.
All right.
And the density of B is 8.9 gram centimeter cube.
Yes.
So to find weight, the formula weight is V rho G.
Weight of A is equals to volume of A into density of
To
A
density of
into G. All right. So this
so
is
volume is 100
100,
into
mhm,
0.3
0.3.
into G. So we cancel centimeter cube.
Mhm.
So we get 30 GF.
Okay, so we get 30 gram force. All right, so here weight of object B is equals to volume of B into density of B into acceleration due to gravity on B.
Yes. Just 100 into 8.9
100 into
into
8.9
G,
into G.
which is 890 gram force.
890 gram force. Okay, good. So let's say upthrust we are finding for the first case, which is for A, which is wood. All right, so what's the formula for that?
V rho G.
Volume of the liquid displaced into density of the liquid into gravity. Okay. Do you know the volume displaced by the wood?
No, sir. So we can use the volume of the A only because like we don't know if it's totally sinking or
See, since it is floating and since the density of wood is lesser than the density of water, you will find that the wood does not sink completely. It only sinks with a part of it inside until we apply some extra force and push it inside. So the question does not say that it has been submerged inside. The question only says that it is partially inside, like it is just floating. So I can assume that it is only partially inside. Hence, this assumption that volume of the liquid displaced and the volume of wood is same is not correct. Then I think we can't use this formula. What is the other way of finding the upthrust? See, there is another way of doing this. If an object is floating, we just know one thing, that the downward force and the upward force is balancing out each other. So instead of calculating buoyancy or the upthrust by this formula, you can just say weight and the upward buoyant forces are same. So you can just say directly that upthrust is equal to the weight, which is we just calculated in the previous part, 30 gram force. Okay, so we don't need this formula. Forward upthrust is equals to the weight because it is floating, it is not sinking. Okay, which is equals to 30 gf. Okay, and then what is buoyancy for B, which is iron?
so for that we should use the formula because it's sinking.
Yeah, because it is sinking. In sinking, don't do that, because you know when the object sinks and goes at the bottom, there are three forces acting on the object. Weight is down, upthrust is up, or the buoyancy is up. Along with that, the surface also applies a contact force, not which is normal. So here weight is being balanced by buoyancy and the surface contact force. Okay. So when it is like when it touches the bottom surface after sinking, additional third force comes into play. That is a contact force, normal force. Okay, a contact force by the bottom surface. So weight balances both. So there I cannot say buoyancy is equals to weight. Buoyancy is only equal to weight till it is floating. Clear?
Yes, sir.
So here for buoyancy, we will use the formula volume of the liquid displaced into density of the liquid into acceleration due to gravity. In this case, can I take volume of liquid as volume of V?
Yes, sir.
Because it is sinking, it is the volume is same. So volume of the liquid displaced, which is 100, into density of the liquid. Correct. So 1 gram per centimeter cube
Into
into,
G.
we'll just leave it as G. So that is 100 gram.
100 gram force.
Okay.